Hi guys, this is John Heron here. I'm joined by Arnaud from
Hi.
Paris. We're here in our Connecticut Training and Education Center. In fact, outside the theater right now, we have about 20 dealers who are being trained on RP22. If you don't know what RP22 is, please go to the CEDIA website and just give me your email address and you'll get a PDF of RP22. It's design guidelines for immersive audio systems, which I suspect most of the people on this podcast would want to be able to learn more about. One of the reasons we're here today is to introduce our new waveforming technology. We recently redid this room to implement waveforming, and I will turn it over to Arnaud to explain a little bit more about what waveforming is and why it does the things it does.
Yeah, thank you, John. So I think this is very exciting time for two reasons. The first one is our new theater and this training facility that is quite amazing. And we are showing the latest in audio innovation in terms of room acoustics, in terms of loudspeakers, bass extension, and we are also very excited to present our new technology, waveforming, which is based on active acoustics. So waveforming is improving the reproduction of low frequencies, and in any small room, any private cinema, low frequency reproduction is the biggest challenge, because the reproduction is dominated by what we call room modes or resonances. So any object resonates, and some parts like a string, a plate, a volume of anything resonates, and some part of the object are vibrating a lot and other parts are not vibrating at all. It's what we call the modes, and it's exactly the same in the room. The volume of air that is contained in the room will vibrate at specific frequencies. And especially in the low frequencies below 100, 120 hertz, there will be some areas in the room where the sound will be very loud and other areas where it will be extremely quiet. And because of that, the sound reproduction is massively non-uniform, and the listeners, they have a very different experience at every seat. And of course, this is not what we want to deliver. We want to deliver the same experience to every seat. And on top of the fact that the sound is not uniform, the decay is very long, meaning that when the sound is reproduced, the sound stays in the room a long time. And the new sound that is reproduced is getting mixed with the previous sound, and it makes the reproduction very confused. So Trinnov has been working over 7-8 years resolving that problem, and this is the waveforming technology. So the idea is that we block the standing waves even before they happen. So we don't even give a chance to the standing wave or the modes to happen. We just block them from the beginning, even before they happen. And the result is that we achieve a consistency within the entire listening area, better than plus minus 1 dB, which is quite exceptional. And we, as part of the training, we do the demo where we play a tone at 50 Hertz, which is exactly the frequency of the second longitudinal mode. And when we don't use the waveforming technology, using the 8 subwoofers, we have a very strong mode. So clearly, when we walk at the front of the room, the sound is very loud, and as we walk toward the back wall, 1/4 of the length, it's almost silent. It's very, very quiet. And when we are in the middle, almost like where we are sitting, it's very, very loud. And then again, when we walk to the back of the room, it's quiet again, and then again very loud. And part of the training is to take an SPL meter and just to measure, and we can measure up to 30 dB of sound pressure difference.
Without waveforming.
Without waveforming,
Yeah.
yes.
And this is an unusually good room, too. There's a lot of acoustic design and treatment in the room. So plus minus 20 or 30 dB is actually quite, unfortunately, quite common. And it historically, people have worked around that by trying to figure out, spaces that are neither terribly loud nor terribly quiet, and just try to locate the seats in compromised positions that are sort of Goldilocks, just the right amount of bass. But as you move around the room, it's impossible for everybody to have that same experience with waveforming because we're preventing the mechanism that causes the standing waves in the first place. Every room and every seat in the house is, as Arnaud said, very, very close to the main listening position and its response.
And our dealer who are participating to the training, so they can take their SPL meter and walk in the entire room, and they can see that the consistency within the entire room is plus minus 1 dB. So this is a new level of consistency in the room. And when I did the first test with my SPL meter app, I thought the app was frozen because as I was walking, the number didn't change.
Yeah.
And this is really a new approach to low frequency reproduction. And the idea is to control what is happening in the entire sound field of the room in 3 dimensions. Up to now, we've been, the technology were based more on signal processing. So we look at microphone signals, we do some processing, and then we output loudspeaker signals. But here, there is a shift in the concept where what we are trying to deal with is no longer measurement points and loudspeakers, but we are trying to control the acoustic field. We are trying to control the acoustic of the room, and it's really what we are doing is controlling how the waves travel through the room. And it's no longer a question of course we need microphone points to measure the waves, but really what we're doing with the waveforming is to create waves that are optimal for the room, so that the waves can travel through the room and then don't bounce off the back wall. And that's really the sound waves that we want to control. And the benefit of thinking in terms of sound waves rather than microphone points is that we control what's happening at the microphone points, but also between the microphone points. And it allows to control the entire listening area, and in that case, the entire room, to a very high level of precision, and being able to guarantee that the result will work not only at the measured points, but also between the points. And not only the consistency, but we can talk about the decay.
Yeah, to me, the consistency is hugely important if you frequently have the entire family watching a movie together, or maybe friends over to watch the Super Bowl, whatever it might be. Ideally you'd want a shared experience, so you want it to be as similar as possible for everyone. But to me, perhaps even more important is the reduction in the decay time at low frequencies. Low frequencies are so long that they're very hard to absorb with passive acoustics. You'd need 3, 4, 5 feet of fiberglass in depth to start working at those very long wavelengths. And nobody's going to do that. So What we do instead is we, launch this nice, well-designed and created wave from the front of the room, and when it reaches the back of the room, we actively absorb it using other subwoofers. And that not only prevents the reflection that introduces standing waves in the first place, but it also reduces the amount of just low-frequency mud that's bouncing around in the room. And when you can get rid of all of that low frequency excessive sound, things that has been bouncing around the room for half a second or more, you can suddenly hear low frequency detail and dynamic contrasts that you maybe have never heard before. And it's quite striking. We had some members of the press here yesterday to do a presentation and so forth. And one of them last night at dinner told me that it was not only a spectacular demo, but it was unlike anything he'd ever heard. So we're off to a good start. Waveforming is somewhat demanding. It's not simply a matter of stick a subwoofer in each of the four corners of the room and push the button. It's a little bit more design work that goes into it, but the results are worth the effort, and it makes a huge difference.
Yes, and we can also introduce that we are introducing a new loudspeaker layout that are less demanding. But maybe I'd like to follow up on what you said about the decay time, because it's possible using the right materials and the right acoustic design to have a very good control of the mid and high frequencies down to probably 150, 100 Hertz, like in this Officina Acustica room where the decay time is very, very controlled down to 100 Hertz. But below, as you say, John, it requires very, very large acoustic materials that we cannot really practically implement. So in studios, like the big rock and roll studios from the 80s would implement bass trap of 2 meters deep at the back of the studio. So that's not something we can implement in a private cinema. And the result is that without waveforming, the acoustic is very well controlled down to the limit of the acoustic, and then it's not controlled at all. And this is where the waveforming is complementing or combines really well with passive acoustics. And in a way, we can think of that as the crossover that usually transition between the mid-high frequency loudspeakers and the subwoofers. Now we can think in terms of acoustic crossover, where now the crossover would do the crossover between the passive acoustic and the active acoustic. And the result is a completely uniform decay time across all frequencies, from the lowest frequencies, 20 Hertz even below, up to 20K or even higher if the speakers can. And this is a very big benefit for the impact of the bass, to have very fast bass, so all the muddiness is removed. But not only, having completely uniform decay time across all frequencies is really improving the tonal balance of the room, because when we use high quality loudspeakers, we know that the direct sound will be flat because of the design of the loudspeaker. But the room will sound as the room decay. And if some frequencies are resonating, some frequencies will last longer, and if others are absorbed, they will disappear very quickly. So as the room acoustic decay, it will decay in a very non-uniform way, creating a very colored sound and unbalanced. And the combination of high quality passive acoustics and waveforming allow a uniform decay across all frequencies, so meaning a room that has no color. So it's a very neutral reproduction. So it's not only about the performance of the decay and the ability to hear every articulation and time domain variation of the sound, but it's also to have to preserve the tonal balance of the content as the acoustic decay. And that's something completely new, and it's a new experience. And maybe we need to talk a little bit about the new subwoofer layout. Yeah, so we are introducing the waveforming to achieve the top performance, the best possible performance. And really at Trinnov, we believe in the design approach, like a high performance private cinema should be designed. So we need to think about where to place the loudspeakers and the subwoofers in that case. And in order to have the performance, it's very important to create the right conditions so that the performance can be delivered. And the placement of the subwoofer is key in the performance. So the waveforming algorithm will only get the best out of what's possible. So we need to create the conditions for the best performance. And we've been publishing guidelines about subwoofer placement with planar array. So it's typically 4 subwoofers at the front, 4 subwoofers at the rear. In smaller room, we can use 2 subwoofers at the front, 2 subwoofers at the rear, and the subwoofers are placed on the wall, not on the floor, but on the wall. Recently, earlier this month, for the high-end show in Munich, we introduced new less demanding subwoofer layout. So instead of trying to do a planar array, we're doing a line array. And as an example, putting a line array of subwoofer on the floor already allow very good performance, so very good uniformity and decay control. Not as good as the planar array. So the planar array is achieving the best performance. So if possible, this is the way to go. But if not, the line array of subwoofer is a good solution. So for the high-end show in Munich, we had 2 line arrays, one at the front with 4 subwoofers, one at the rear with 4 subwoofers. In this room, 1 month ago, we did experimentation with Jon and Dave, moving subwoofers around and actually measure the performance we have with many different subwoofer layouts. And we did a line array of 5 subwoofers, and the result was really good. Not as good as the planar array on the wall, but still really good. And the smallest line array that we support is with 2 subwoofers at the front and 2 subwoofers at the rear. And the ideal position is 1/4 of the width of the room. And
so 1/4 and 3/4.
Yes, 1/4 and 3/4. So for the front and for the rear. And we are also supporting more conventional subwoofer layout, where the subwoofers are placed at the 4 corners. In that case, there is a real compromise in terms of the performance. So the uniformity, the size of the listening area will be clearly compromised. And the ability of the system to create the first wavefront that is essential to achieve the highest performance will not really be possible because the 2 subwoofers will be too far apart. This being said, there is already a good level of improvement compared to more traditional low frequency optimization.
But excuse me, Arnaud, the line array, meaning putting subs on the floor at the front of the room and at the back of the room, creates a cylindrical wave, which is not quite as good as a planar wave, but it still is well defined. You get all the benefits of the decay time control, the uniformity from one row of seating to the next, not quite as good as the planar array. But of course, the planar array is not really an option if you have a micro LED wall, for example, or if you have a projection screen that's not acoustically transparent. So it's the line array at the bottom of the front and rear walls addresses a very real-world problem as we move into more and more of these very large, non-acoustically transparent display technologies.
And we can do the subwoofer placement the other way around, like starting from a traditional subwoofer placement with 4 subwoofers at the 4 corners of the room. And if you have the possibility to bring the subwoofers a little bit in, like 1/4 of the width of the room, you will already have a very significant improvement in performance. And this is not because today subwoofers can perform really well, and by just moving them a little bit in the room and having the opportunity to achieve the best performance they can, I think it's worth making the effort to bring them a little bit in. And then if you can move them up so that they are at the middle of the room height, then that's the optimal subwoofer layout for 2 subwoofers, for an array of 2 in a smaller.
People, I get emails quite often asking, what is the perfect layout? And there isn't a single perfect layout because it depends a great deal on the size of the room. One of the things that waveforming does in order to create a nice uniform wavefront is we are steering the bass by using the multiple subwoofers to create a sort of a virtual subwoofer of all of them working together. Well, the upper limit of frequency to which we can steer things is determined by how close the subs are to each other. They have to be within a half a wavelength of each other for us to be able to steer them effectively. So if you want to control things up to 80 hertz, they have to be this far apart. If you want to control it up to 120 hertz, they'd have to be even closer together because the waves are shorter. Well, so it's the overall density of subwoofers on the wall that will give us the ability to control things as nicely as we'd like. And then once you establish that, how big the wall is determines on how many subs you need to maintain that density over the wall. And again, or that density in a line at the bottom of the wall if you're using our new cylindrical waveforming.
And about 1 month ago, we released, in addition to our recommendation for subwoofer placement, we released an online subwoofer placement simulation tool. So that will give you the optimal subwoofer placement based on the dimensions of your room. So that it's a very, very simple tool to use. You just have to enter the width and the height of the room, and then the software will automatically give you the best subwoofer placement for that room. And then you can just change the dimensions and see like if the room becomes wider, then you need more subwoofers, and if the ceiling height is higher, then you need more rows of subwoofers. But as the performance will be predetermined by the subwoofer placement, we highly recommend to check this tool before starting a project to make sure that the project is correctly designed, and then at the end the effective performance will be achieved.
You can find this tool that's been posted for about a month now on the Trinnov.com website. And then one last thing we should probably mention is that we've also made it possible to take advantage of the fact that in many waveforming installations you'll have more subwoofers than you might have otherwise. So below the lowest frequency of the standing waves in the room, we can actually alter the way we use in this case, 8 subwoofers. So they're all working together as a team to pressurize the room at infrasonic frequencies. So we can control not only the propagation of sound through the room, but also the pressurization into infrasonic frequencies. And I haven't been here for the most recent tuning of this room, but you maybe can tell us where we reach in this room at this point.
So the waveforming is more like a combination of technologies, and basically we form waves, so it's based on the control of waves, and to have the best possible performance we need to create wave propagation in the room, so that's what gives the best performance. But to achieve that we need to introduce some amount of active absorption to reduce the decay, and this active absorption is reducing the efficiency of the system. So it works well down to usually 20 Hertz, but to go in the subsonic domain, the real challenge is to have the sound pressure level. So in that case, the waveforming technology is working in pressurization mode, which means that we are using all the subwoofer together to pressurize the room. So instead of like launching a wave using the front array, we use all the subwoofer together in a sort of 3D volumetric array that is pressurizing the room and creating a uniform sound pressure level. So the array itself is creating a uniform sound pressure, but the room is... So waveforming is working in 2 modes. So the highest performance is when waveforming is working in propagation mode, meaning that the front array is producing a wavefront that is traveling the room, and the rear array is absorbing. So this delivered the highest performance, but because of the absorption, this is not the most efficient reproduction. So this is really good down to 20 Hertz, but below 20 Hertz, when we go into the infrasonic domain, the biggest challenge is to achieve the SPL level, the sound pressure. And we have to use all the subwoofers in the most efficient way. So we are looking for efficiency, and so the waveforming is working in pressurization mode. So all available subwoofers will be used in phase, creating not only a front planar array, but a 3D volumetric array, including the front subwoofers, but also the rear subwoofers. And this array will create on its own a uniform sound pressure, a uniform pressure field. And on top of that, the room, depending on its ability to pressurize, which really depends on the rooms, but the room itself will be used as a pressure chamber. And some rooms will pressurize better than others. But in any case, the waveforming pressurization will allow to have a much higher sound pressure level, and which will allow to extend the frequency range to the lowest frequencies, while maintaining the sound pressure level and a reasonable level of distortion. So the pressurization mode is really dedicated to subsonic reproduction. And in that particular case, we're using pressurization mode down to 16 Hertz. So the waveforming
Down to
16,
okay.
6. Yeah. So so we maximize propagation and sound quality down to 16 Hertz, and then we pressurize below 16 Hertz to reach the lowest possible frequencies. And this is an evolution of so pressurization is an extension of the waveforming technology that we introduced earlier this year. And waveforming is really a big change in the way that low frequencies are reproduced, and there will be continuous improvement of the technology over the coming years. And my guess is that there will be a series of innovation over the next 5 years, the coming 5 years, possibly 10 years. So it's really a big technology step, and this is why it's very exciting to open our new theater, but also introduce the waveforming technology. So that's very exciting time.
And of course, the main reason for the theater is so that we can teach our dealers how to implement these things, not only in terms of, which buttons to push and everything, but from the very beginning, how to design a theater so as to get the optimal results. Because it's not just about all the cool things the altitude can do. It's also an overall design effort to make sure that the passive acoustic and the active acoustics sort of dovetail with one another and take care of the entire room.